So the wormhole in Interstellar was a logical consequence of gravity, our theory of gravity or general relativity. Basically what it is that if we had access to some extra spatial dimension that we currently don't have access to and we can't verify exists, if we did have access to that, then we could potentially move through that, whatever that means, move through this extra spatial dimension to make regular spatial travel much quicker. You know, it's not crazy, it's just one of the many things that, one of the many plausible ways that, that new physics could be found. Yeah, so in the movie, they go through this wormhole and it spits them out in some faraway galaxy, and they're really near a supermassive black hole that's spinning really quickly. And one of the possible habitable worlds is really near the event horizon of this black hole. And they are worried about time dilation effects, where the observer that stays far away from the black hole will experience time differently than the people that go close to the black hole. And this is real physics too. When you have a supermassive black hole, apparently this one is something like 100 million solar masses or something, I forget what it was, but the consequence of this gigantic black hole that is spinning so quickly is that it warps the fabric of space and time in such a way that time itself slows down for you. So then when you go back and get back in contact with the person that you left behind, your clocks will be totally different. And this is real physics too. So in the movie, when our hero, Cooper, finally goes into the black hole and he goes through some crazy 2001 style visualization and finds himself in hyperdimensional tesseract that allows him to go back in time and see his daughter's bookshelf. This is where the movie gets into really speculative territory. It's not to say that it's wrong, it's just that it's not necessarily things that we're going to be able to verify anytime soon. I don't think we're going to be able to send anybody into a black hole anytime soon. But one of the things that it does get right is this concept of extra spatial dimensions that we could have access to somehow. And this is something that's not crazy, and in fact it's a very plausible way to explain a lot of the things that we don't understand currently about fundamental physics. And it's actually one of the things that we could potentially probe at the LHC. When we collide protons together at such high energies, we have the possibility of creating new states that could indicate that there are extra spatial dimensions. We don't currently see any evidence for this in the previous LHC data, but at 13 TeV we have the best, this is the highest energy that mankind has ever used in a collider experiment, so we have the best chance of being able to access this that we've ever had before. So in the movie there's this idea that they need to, the thing that they need to get back to the scientists on Earth is how things are behaving in a black hole, and somehow get this information back to Earth so that they can then manipulate gravity. This is essential, and it's interesting, it's essentially coming from the fact that gravity, in terms of the fundamental forces that we know of, is kind of the odd man out, and especially for an LHC physicist, because gravity is the force that we pretty much ignore in our calculations of proton collisions, because it's so weak compared to the other forces of nature that it never enters into our collisions, except in the sense that we could potentially probe these extensions of gravity, these theoretical extensions of gravity that predict extra spatial dimensions. And at the LHC, we have the possibility of, it's a very speculative thing, but we have the possibility of creating these new states that could indicate to us that there are actual other spatial dimensions. And this would be a fantastic discovery. We have the possibility of creating these microscopic black holes which satisfy the same equations of the gigantic supermassive black hole that you see in the movie. And in that sense, we're probing the similar physics. It's not on the same energy scale, and we're not going to create a supermassive black hole that's sucking the Earth at the LHC. But it's the same equations, and it will allow us to probe similar ideas. So the scene in the movie where Anne Hathaway's character talks about the possibility of love being a force, that's where the stomach, the physicist's stomach starts to churn a little bit, because we have a lot of respect for these word forces, and we wouldn't describe love as a force. There's a lot of reasons. There's a lot of reasons to think that there are hidden forces out there that we don't have access to currently, that we might be able to probe at the LHC. But unfortunately, love is not one of them. But Matt Damon's death in that movie was fantastic. It was amazing. One of the best science fiction deaths, where he's about to make this grand speech about there comes a moment, crash. Fantastic.